So this is the second video in our series, and we have looked at a similar problem in the last video, but the only difference was that our p-value was parallel. So this p was parallel to the inclined face. So instead of having p like that at an angle, it was looking more like that arrow there. And this analysis, it's going to be similar, but there are a lot to kind of bear in mind. But just before we go there, just as a reminder from the previous video, we had this formula that we used for frictional force, which gave us the coefficient of friction multiplied by the normal reaction. So that was one of the formulas that we looked at. We also worked out the normal reaction, its component. We did that as well. And the component for the normal reaction there was mass multiplied by gravity and cos, then the angle. And then the other thing that we worked out was the pulling force, the resisting force that's going in the opposite direction of P. So that's that force there. And that turned out to be, again, another component of gravity, which was mass times gravity, but sin, and then the angle. Now, this is where we're at. We are going to do a similar analysis with our pulling force. And because of its orientation, I'm just going to do a sketch that isolates this P right here. So that's the P right there. And if I'm to input this here, this would be where we have our 15 degrees angle right there. So because P and that horizontal line there, it's parallel, it therefore means that the angle between P and the inclined plane will also be 15 degrees. Now, the next thing that we would need to evaluate are the components, which is going to be relatively straightforward. So for P, we're going to have another reaction force like that, and another force going like that parallel to the inclined plane. And for this face right there, that's just going to be P sin, and then the angle, which we already know to be 15. And then the other face here is again going to be P cos, and then the angle. And that's all we really need in order to analyze and to work out that force for P that's going to just about get the system start moving. So let's get into some deeper analysis. So the first thing that we're going to do is basically balance our forces. And to do that, we can say that the forces going upwards should be equal to the forces going down. Okay, so what that means is, if you look on our diagram here, the only arrow that we will have pointing upward would be this normal reaction force there. So what that means then, we would end up with just N for normal reaction, because that's the only force that's going upward, and the component of gravity, which was mass times gravity and cos angle. So we will also have the component of P, and that's this bit here that we've worked out to be P sin, and then the angle there. So that's only two components there that's going upward. So that's the upward components that we would have figured out. Now, the other set of components that we will have to look at are the ones that are parallel to the plane. So those were the ones that's going upwards, or the ones that's perpendicular to the plane. So this is the set of components that are parallel to, I'll just write plane, which would be P cos, then the angle, and this bit now will be equal to the ones going in the opposite direction. So the ones that's going against this P, or the pulling component, which would then be the force. So this F is this one here. That's going in the opposite direction of where the P is trying to go. So that's that F plus the same mass times gravity sin angle component. So those are our two sets of equations, and we have most of the values ready. And where we have this F right here, we're just going to, that frictional force F, we're just going to substitute what we already know to be the frictional force and the normal reaction stuff that we can find, because we have the mass and we have gravity. Now, I don't want to just throw things on the screen as just wild formula, so I'm going to break this down step by step. So stick with me and you will understand everything from start to finish. So we're going to build on this last formula right here, the very last one that we have here. And for the P cos theta, we're going to replace that F with the previous formula that we had, which was the coefficient of friction times normal reaction. So all that will change now here is this F is going to be replaced by this here, coefficient of friction times by normal reaction, and plus mg sin theta. Now, the purpose of this is so that we isolate the normal reaction, and that's because we no longer have just one force that's our normal reaction. It's no longer just the mass times gravity, but we also have to factor in that component that we get from P. So let's rearrange this now so that we get N as the subject. So if we then just subtract this bit from both sides, then what we'll end up with is just frictional force times normal reaction is equal to P cos theta and minus mg sin theta. So N is then equal to P cos theta minus mg sin theta, and all divided by friction. So that's the first bit done. So what we're going to do now, so that we have only P as the unknown, because that's what we're interested in, that's what we're trying to find. If we come back to this formula here, this one, then what we're going to do is substitute that N for what we just worked out to be N. And once we do that, you will see where the only unknown in that equation is P. And that's going to give us our pulling force. So let's do that now. So this was the part of the formula that we looked at up top. So mass times gravity cos angle plus P times sin theta. And this is going to be equal to N, which is what we just found here, which is our P cos theta minus mass times gravity sin theta, all divided by coefficient of friction. So now the only unknown in this equation is just P. So we are going to use this now to work out our P. So for the left hand side, so mass times gravity, so 25 times 9.81, cos we know our angle is 15 degrees, plus our unknown here, which is P sin and 15 degrees. So far, only unknown is P. This will be equal to, so it's going to be P cos 15 degrees, again, our coefficient of friction, which is 0.3, minus this next bit, mass times gravity, so 25 times 9.81, and sin 15 all over or 0.3. So throughout our entire equation, the only thing that we have as unknown so far is just P. So now it's just to simplify what we have. So if we simplify all of this bit here, pop that in your calculator, what you would end up with is just 237 and plus 15 sin 15 is 0.259 times p equals, on this side, simplifying again, so all of this here is just 3.22 p and minus 211.8. So then to solve, we just need to group our like terms, which is we want to get the p's on one side by themselves. So that would be 3.22 p minus 0.259 p equals 237 and plus 211.8. So our last steps then, so 2.961 p will be equal to 448.8, and p is just going to be us dividing 448.8 by our 2.961 to get our final answer here, 151.6 newtons. Now, if this is the sort of content that you would like to see, then just please leave a comment to let me know that yes, you would like more of this type content, or if you'd like, you can just leave a suggestion for other types of contents that you would like to see.